Section 5.2, number 71. Just straightforward, they're asking you to evaluate a definite integral here, but I want to remind everybody that in Section 5.2, from whence this problem came, all we're doing here, guys, is we are using either area or the properties of definite integrals that we learned to evaluate those integrals. And one thing you guys have to make sure that you get down here, anytime you're evaluating an integral with an absolute value, which this one has, we are going to use area in order to evaluate that integral, okay? Anytime with an absolute value. So that probably bothered some people, even if I told you that, because they might have thought we don't know what that graph looks like. So let's talk about this. Most people know that the absolute value of a linear function is going to get you a V shape. But the first question I would ask then is, where is the vertex of that V located? And people get bothered by the fact that this expression, this binomial inside the absolute value, is not in the order that they like. We generally would like the x to come first and then a plus or minus 3 or 7 or 12 or whatever to come after that. Well, we're kind of missing the important point here. The vertex of an absolute value graph occurs anywhere that this expression right here will equal 0. So what value of x will make 3 minus x equal 0? That answer is 3. So that, you're going to see this here if you don't believe me, but that is where this graph kind of begins. All right, so at that value of 3, and then let's just think about what happens now. When x is 3, 3 minus 3 is 0, and the absolute value of 0 is 0. So this graph should begin right there at the point 3, 0. Now, what I'm hoping you guys know is that, we've talked about this before, if I were to ask you what 10 minus 2 is, the answer is 8. If I switch the order of those numbers around, 2 minus 10, that's negative 8. When you change the order of subtraction, you get opposites. But if I put absolute value around that, the absolute value of 10 minus 2 is still 8. But the absolute value of 2 minus 10, well, that means to take the absolute value of negative 8, which is also 8. So the order of subtraction inside an absolute value doesn't really matter at all. That means that this function is really the exact same thing as the absolute value of x minus 3. Now, I only bring that up, guys, because with a normal absolute value graph, your slopes are going to be positive 1 off here to the right, and then negative 1 off here to the left, and that's the exact same thing that happens here. Now, if you're not 100% sure about that, think about a point that you believe is on this graph, like 0, 3, and guys, we lose sight of what we're doing when we graph. We've been doing this for years. If we've graphed this right, this point should work on this function. When x is 0, y should be 3. 3 minus 0 is 3, and the absolute value of 3 is 3. And let's see, I think I also have the point 6, 3 right here. When x is 6, y should be 3. 3 minus 6 is negative 3, and the absolute value of negative 3 is positive 3. So the fact that I've checked, that was ugly. The fact that I tried 3 different points right here, okay, 0, 3, 3, 0, and 6, 3, and got all of them to work here, tells me that I think I graphed this thing correctly, okay? That's kind of how your thought process might guide you through on a problem like this. Now, back to the issue at hand. We're supposed to use this graph now, the area between the curve and the x-axis, starting at x equals 0, our lower limit of integration, and ending when x is 6, our upper limit of integration. So I've got two regions, guys, this triangle right here and this triangle right here. We need to find the net or signed area of each one of those regions and add the two of them together. Okay, so let me pull this down now that I've kind of made a mess here, and let's get to it, guys. So we've got a triangle located entirely above the x-axis. Its area is going to be 1/2 times a base right here of 3 and a height of 3 as well. And then we're going to add to that the area of triangle number 2. 1/2 times, another base of 3 and another height of 3. So you probably noticed 1 and 2 have the exact same areas. So that's 9. Half of that is going to be 4, and now let's just do it that way. 4.5 plus another 4.5. You'll notice both these regions are entirely above the x-axis, so of course our answer has to be positive, and in this case it ends up being 9. There are no units on a definite integral problem, guys. You wouldn't put square units unless they specifically said find the area between the curve and the x-axis. So our answer here for number 71 is 9.